fundamentals on YouTube. Please, before we go into today's presentation under mathematics, please do not forget to share, comment, and subscribe to my YouTube channel. Thank you so much. Today, we are taking mathematics, and the topic here is analytical geometry. Analytical geometry is investigating some parameters under geometry. And what is geometry? Geometry is a way of showing mathematical expression in a physical way. How to let mathematical expression be seen in a real life situation. That is what geometry is all about through a layman language. Now, under this analytical geometry, we are taking the subtopic, and that subtopic is slope. And let me give you an idea of what is slope. Let's consider vertical as its y and the horizontal as its x. You see, if I have a line here and I rotate this line, rotation means taking angle. I rotate this line and my amount of rotation is less than 90 degrees. That angle is known as acute angle. So let's say my rotation reaches this place after I've rotated, and the amount of rotation is called angle theta. And this angle theta is an acute angle. Acute angle. Now, this particular line coming from the origin, the coordinate of point at this origin is 0, 0. And the coordinates at the end of this point, let's take it as point P. The coordinate is any arbitrary x, y. That's the coordinate for this point. We are continuing this straight line. Now, consider a vehicle moving from this origin towards this direction along this straight line. You know that it will experience an amount of difficulty in climbing, difficulty in climbing this line. So when we think about the degree of difficulty in climbing a line inclined at an angle, at an acute angle to the horizontal line, that measurement of the degree of difficulty is called a slope. In this case, the angle is acute angle. So my definition 1 on slope. Slope can be thought of as degree of difficulty of an object in climbing an inclined line to the horizontal. Now, if you look at this place now, if I take a vertical line to this side, you can see that as I'm moving this line towards this side, the value along the y-axis, the change in y-axis will be positive change. As I'm moving that line also, the change in x-axis will be positive change. So the slope mathematically can be thought of as a change in y divided by a change in x. So for this particular line, the slope is positive. And then this change in y can be taken to be rising or rises. I mean, rises means increments in the value of y along this place as this line is moving. And as this line is moving too, the value of x is also increasing. So this change in x can be thought of as runs along the x-axis. So that is the situation when you incline the line at an acute angle to the horizontal. So when you do this inclination at acute angle theta to the horizontal, we define slope as a degree of difficulty of an object in climbing an inclined line to the horizontal. So this object will find it difficult to climb up. Now, consider this second scenario of slope. let's say the line is being inclined at a acute angle to the horizontal. When we rotate that line from the x-axis, and the value of that angle is obtuse. Obtuse angle is an angle that is greater than angle 90 degree. You see, when we have a scenario like this, if we have an object here coming from this point going downward, there will be easiness of the object in descending that particular inclined line. So this object will move under gravity easily down here. So when we have a slope of this nature, you can think of that as this object is moving down, the value of your y along this place is decreasing. If you look at this place now, when the object reaches this side, the value of your y here is decreasing. When the object reaches this side, the value of your y here is decreasing. And as y is decreasing, the value of the x is increasing. So here we have increment along the x-axis, but decrement along the y-axis. As y decreases, as this object is descending, the value of y is decreasing, is changing y. So this particular place can be thought of as fall along the vertical, not right this time around, and this place still remains as a runs. So by definition of slope can be taken as change in y for this particular line that is inclined at an angle, obtuse angle greater than 90 degree to the horizontal. The slope is minus delta y divided by plus delta x. Delta y means change in y, delta x means change in x. Minus divided by plus will give you minus. So we have delta y all over delta x, and this is a negative. So in a nutshell, I've defined the slope. When the line is inclined at an acute angle, the slope is positive. When the line is inclined at an obtuse angle, the slope is negative. So in a nutshell, in order to combine this scenario, these physical implications in these two cases together, I can define my slope as a measure of degree of difficulty in climbing a straight line inclined at angle less than 90 degrees. That is a acute angle to the horizontal x-axis, or a measure of the degree of easiness in descending. That means coming down. In descending, that is coming down a line inclined at obtuse angle, that is angle that is angle theta that is greater than 90 degree to the horizontal x axis. So this particular slope now can be generally expressed as change in y divided by change in x. So the change can be positive or negative for y. The change can be positive or negative for x. So I would rather write this as plus or minus here. So now, to summarize different aspects of slope, let me now show you something. If we have a line that is inclined this way, call it slope m1, and the line that is inclined this place, call it slope m2, and the line that is horizontal, call it slope m3, and the line that is vertical, call it slope m4. Now, if you go to slope m1, as an object is moving upward, there is a rise that is positive change in y and positive change in x. So m1 will be plus delta y divided by delta x. So this slope here is positive. So m1 is positive. Now, as the object is moving from here down, the the height will be decreasing while the x is increasing. So the slope here will be minus delta y divided by plus delta x. So this slope for m2 is negative. Now, if you look at this particular place here for the horizontal, as the object is moving here, there is no rise, there is no fall in y. So the value of delta y is 0, while delta x is positive. So from the definition of slope, m3 will be delta y divided by delta x, which is 0 divided by plus delta x, which is 0. So that means the slope of an horizontal line is 0. Now, if you look at this vertical line, there is a change. If you are moving from here up, there is a change along the vertical, positive change, but there is no change along the horizontal. So the slope m4 will be plus delta y divided by by 0. So this slope here is infinite, that is undefined. So that means vertical slope, vertical line slope is undefined. That means we cannot get the value for it, undefined. So horizontal line slope, horizontal line, I'm talking about this vertical, then horizontal line, this particular line, slope m is 0. So I believe that from the onset we have learned about the concept of slope, but generally I can write my slope s as delta y divided by delta x, which is the new position of y. That is why to take away initial position of y, that is y1 divided by new position along the x-axis minus initial position along the x-axis. So this is a standard formula for slope of a straight line graph. Thank you.